24/7 Synthwave with all your favorite artists.
What's up? This is Miami Nights 1984.
This is Celerec LA Dream.
This is FM 84.
Hey everyone, this is Arcade High.
I'm Alex, aka Highway Superstar.
This is Night Ride FM.
What's up, hackers? Welcome to Chill Code. My name is Taggart, and tonight, fairly special evening here at the Taggart Institute, in which we are celebrating the launch of our second course in, 3 weeks? Something like that. And not just the second course, but our first paid course. So, yes, we are actually asking for money for one of these things, and the reason we're doing so is to help support the development of more free courses on the Institute in general. So some of the more advanced stuff is paid, not going to be expensive. So I'm delighted to finally release Python for Defenders Part 2, Defend with Data. Python for Defenders Part 1 has been out for a while. It is a free course that will introduce you not just to Jupyter as a concept and developing Jupyter notebooks, but also to the Python programming language in general. If you've never worked with Python and you've done some other kinds of programming, then Python for Defenders is a great intro into how Python works in the context of Jupyter, especially if you are in a defensive cybersecurity role. Both of these courses are designed to empower defenders with the power of programming. A lot of folks in defensive cybersecurity roles don't have programming skills, and to be fair, you do not need them, right, to be successful. You don't have to be a programmer to be successful as a defender. But if you can, your capabilities multiply in some really exciting ways. And if you can expand that skill set into the rest of your team through repeatable, documented processes, then all of a sudden you can do things that the attackers can't. You can certainly do things that other defenders can't. And that is why I was so passionate about getting this material out into folks' hands. Part 1 and Part 2. So Part 2 is really about understanding how to work with data in all sorts of shapes and sizes. So I want to give you a quick tour of the course here tonight, and we're also going to do one of the more fun labs that I really like inside of the course, where we build our own RSS reader inside of Jupyter. And you might think, why would you want to do that? Well, because then you have full control over how the data is parsed, how it's displayed, and then where it goes from there. So we're going to play with that, but first, just a quick tour of the course in general. So the entire course is built inside of Jupyter Lab. There are video components where you have to endure me talking for quite a bit of time, but the video demonstrations are overviews of the same material with some slight differences that are covered inside of the Jupyter notebooks. And the idea is that with the Jupyter notebooks, these are fully written. It took me a long time to write all these out with full compiled demos, right? Every bit of the code runs inside of the Jupyter notebooks. But the idea is that you then go and reproduce those concepts in your own notebook, taking those as templates. And as you do so, you will learn how to put together a notebook that is not only functional, but also pleasing and Yeah, so one of the things we talk about in the course is that there is a user interface component to Jupyter Notebooks, right? You have to think about your audience that you're writing the notebook for. It's probably not just you, it's for the other people on your team who are going to use it, and also for anybody who may have to read the output of your notebook, which is why we even have a section on reporting, how to get the data out of your notebook in an attractive way. Let's go through the curriculum briefly. We can talk about that. Get that page out. Yeah. So the curriculum looks a little bit like this. We cover, we start at part 2 because the idea is that you really should do part 1 before you go into part 2. And so if you've purchased the course, first of all, thank you very much. But then go back and do part 1. The part 1 is part of the course, right? It's just that it was free. So part 1 is also where we set up the virtual machine. If you're using the virtual machine, we explain poetry and how to set up Jupyter. So all of that is in part 1. It's really important. But once you have that covered, come back to part 2, and we'll talk about the details of writing in Markdown. So part 2, section 2 is called writing, and it's all about how to compose appealing and useful Jupyter notebooks. Markdown, how to use Markdown effectively. We even have some tricks about how to do footnotes inside of Markdown, which is something that I think, depending on how academic your notebook is, may be of value. Let me show you the footnote thing, because that's kind of cool. A lot of folks don't know about that. Yeah, so here, if you do footnotes, you can actually use superscript tags, and you can link directly inside of notebooks. So like this will take me down, if I'm running the code, it will. To the notes section here. And that heading allows me to link directly to it. So if you want to have a references section, that's good too, but you can also have inline notes and of course hyperlinks as usual. Just some good writing stuff. I can't help it. There is an academic flavor to Jupyter Notebooks because of their usage in data science and other sorts of computer science and not just computer science, though. I should be careful with that. In academic realms. And so the way in which notebooks can be formatted, we think about how do you cite sources. What else we got going on? After writing comes parsing, where we talk about in detail how to get data into a Jupyter notebook in a way that is useful to you. So yes, we talk about how to open files, but then we talk about specifically how to handle CSVs in useful ways. And I bet that even if you've done CSV parsing inside of Python, I bet that you'll learn a couple of tricks in that section that you may not have been aware of. Same with JSON, how to handle JSON effectively inside of Jupyter or Python in general. Nothing that we do really inside of parsing is Python specific. And then we do take a quick detour onto regular expressions. We don't teach regular expressions because there's a free course to do that in the Institute, but we do talk about how to use regular expressions in Python for maximum effect. Things like how do you custom parse logs that have a format that is a little bit wacky. Like Apache logs, which are really annoying to parse, it turns out, but there's a breakdown of how to do it with regex in here. And then, we have some labs. This one is kind of cool. It's an indicator of compromise extractor. So basically you give it a bunch of files and it will pull out indicators of compromise from it. So if you give it like a CSV, it will pull indicators. If you give it a PDF, it'll pull indicators. If you give it a text file, an HTML file, whatever it is, it knows how to parse. And you write the extractor from scratch. Teaching it how to detect indicators of compromise. Hey, Frackery. Yeah, I saw that too. I was confused about that, but good to see you. After we talk about parsing, we talk about connecting. How do you take your notebook and then connect it to other elements, other resources, specifically network resources? So how do you connect over HTTP? How do you make use of APIs? We talk about at least 3 specific APIs. One of them is the VirusTotal API. We also talk about the Wapalyzer API. And how do you integrate those flows into a notebook? And then for custom work, and this is actually some of what we're going to do tonight, scraping. How, for things that don't have an API, how can you pull that information into your notebook in a reasonable way and parse the data that you need when there isn't an API giving you clean data to work with? At that point, we kind of kick into high gear. Sections 5 and 6 are really the core of the course, where we're talking about data science. VirusTotal does have a free API, Brins. You have some limits on requests, but they're totally reasonable limits. And yeah, there is a free API. You can use it to pull down data. If we have time tonight, we'll check out that section because it's pretty cool. Right, so section 5 is analyzing. How do you take the data that you've ingested and really do something interesting with it? And this is where we start dipping our toes into some of the skill sets used in data science. So we talk a lot about pandas, which is kind of the core library for data analytics. Then we talk about diving into the data frames that you make with pandas, doing some exploratory data analysis, quantitative analysis. And then we teach you how to make pretty pictures with visualization. And the thing with visualization is that it's not just visualization, it's also how do you analyze data across n dimensions? Meaning that when you think about looking at stuff in a spreadsheet, right? You are kind of by definition, until you get to like pivot tables, you're by definition analyzing 2 dimensions of data. Okay? But if you add extra ways of representing the data like color into a chart, now you can analyze on more than 1 dimension or more than 2 dimensions at a time. And that is crazy powerful. We also go through how to handle time series inside of Jupyter and use pandas. So time is really tricky to program around, and so there are a few tricks that I've put together for how to reasonably work with time data inside of Jupyter and how to get it out of logging data like Sysmon events or something like that. And then, of course, reporting. We do just a little bit on reporting. And then institutionalizing. Once you have these skills, how do you bring them to the rest of your team? How do you start building processes that are repeatable and have a change management process? Oh, Thief, thank you so much. I really appreciate that. We talk about some cool community projects that are built with Jupyter, so you're aware of the other work that's going on in this realm, things like Mystic Pi and Dissect for Defer. And then, yeah, we talk about your Exhibition of Mastery, which is sort of a core concept that we have at the Institute, where you have to prove to yourself that you have mastered the skills that you set out to master when you purchased the course or enrolled in the course. You have to prove it to yourself. We give you some guidelines on how you could do that, and then we encourage you to share your success in our community in the Discord. That is it. That is the shape of Python for Defenders Part 2. So it might seem, I don't know if it seems, high level. It is definitely a jumping off point. There may in the future be a Python for Defenders Part 3 where we go deeper and talk a little bit about how to use things like supervised learning to start making predictions about data, right? A little bit of machine learning in there, because once you have the tools of pandas and data frames, that machine learning component is not that far away from all of that skill set that you've already built. And this is really where I kind of want to go, because for me personally too, because I believe that those are the technologies that are going to govern, well, civilization in some ways, but certainly going to govern our profession moving forward, right? That is the stuff that cannot be automated. Even if you think about the crazy things you can do right now with ChatGPT, right? If you've played with that model. Here's the thing about that. So, I mean, it's unsupervised learning, but the process still had to be designed, which means there is some level at which somebody is putting that pipeline together. And I feel like once that starts filtering down into more commoditized tools, it will be the defenders who understand how to take advantage of those tools who will be at the cutting edge of defense. And that's where you want to be, because for sure the attackers are going to do the same thing. We've already seen folks try to use those models to build phishing lures and even build malware samples. So anyway, that's kind of like my far-flung vision. But let's write some Python. Pivot tables are beautiful. I agree, Frackery. All right, let's write some Python. So we're going to write an RSS reader with Python. To do so, we're going to need a couple of imports. The first one is... Oh yeah, well obviously we're going to need requests. So we're going to import requests. Requests is the not built in, but kind of bog standard HTTP request library. And the other one that we're going to import, if you've been around this part of Python at all, you'll be familiar with it. BS4 import Beautiful Soup. And if you're not familiar with Beautiful Soup, boy, do I have a present for you. Beautiful Soup is indeed beautiful. It is a parser for both HTML and XML that takes a raw string of that kind of data and gives it object structure inside of Python. So you can kind of see, we get a title, we can get the string, we can get the attributes. We can use find all as though we were using something like jQuery. And so here's the cool thing about Beautiful Soup though, and this is why it's even more OP for us. It's not just HTML. Beautiful Soup can be used for XML as well, which means you can use Beautiful Soup for stuff like sysmon logs or any EVTX logs. So with that, you can scalp and harvest. I think the word you're looking for, Quaffle, is scrape and harvest, and yes, the answer is yes. Probably not the first thing. So let's go get some data. As I said, we're going to do an RSS reader. And to do that, we need some RSS. Oh, the other thing I'm going to do, I'm going to mix it up a little bit. Oh, if you're interested in sysmon logs, I just have to say the sysmon stuff that we do in this course is off the chain. Here's why. Look at this. I wrote for you a custom parser for sysmon logs that produces Python objects with sysmon data inside of them. And what we do inside of the labs is take this and turn all of these objects into columns in Pandas data frames, allowing you to analyze sysmon events. You can do charts by event ID. It's as though you were in Splunk, but you're doing it right from raw data. So yeah, pretty cool. Thank you, Sar. I'm excited. So, as I said, one of the other things we talk about in the course is user interface design with Jupyter Notebooks, which you can, in fact, do. So, we're going to do import IPyWidgets as widgets and from IPython.display import display. So, and we'll do some good commenting, right? Import our Deps, our Johnny Deps. IPython is capital I. There we go. All right, so we have our dependencies, and the reason we're using widgets is that widgets allow you to generate user interface components inside of Python, inside of Jupyter. So for example, check this out. Slider equals int slider, or widgets dot int slider, value equals 0, min equals 0, max equals 100. I'm doing this from memory, but I think it's right. And display slider. And then I've got, look, I have a slider, which is storing its state. So if I ask for slider.value, it's storing its state. So I can use this to build an actual user interface inside of my notebook. All right, so we have all this. Could you use this for multi-server diagnostics, if that's correct? Oh, you want to do like a monitoring dashboard? You can. I think that tools like Grafana probably do that better out of the box, but you could do it, right? Or even just Nagios, right? But yeah, you can do. So say, for example, you were pulling in a bunch of threat intel or something like that, and you didn't want to pay for Splunk, because why would you? You could use something like a Jupyter Notebook to produce a dashboard for, you know, how many hits do you have on the threat intel IOCs or something like that. It's just off the top of my head. The way that I see Jupyter really playing into a SOC, a security environment, is for repeatable procedures that are complex enough that you kind of doing them manually sucks, but they're also parameterizable, meaning that if you give enough reasonable inputs, that an automated process could do them. And so I'll give you a good example. Something that you could do with a Jupyter Notebook, and that I have done, is setting up assets for ad hoc vulnerability scans. So say you had a vulnerability scanning tool like Greenbone Vulnerability Manager or Nessus or Nexpose. Let's say you had one of those and you wanted to provide a way to kind of make kicking off scans for different asset groups a little bit easier, or dynamic asset groups, making that a little bit easier. You could hook into the APIs of those tools with a Jupyter Notebook and provide that as sort of a front end. And so you don't have to worry about authentication, you don't have to worry about anything else. You just have this API key that is kicking these things off with parameters that you've defined. All right, so RSS reader, we need an RSS feed to start with. We'll do the base one and then we'll add others. By the way, fun fact, did you know that every Mastodon URL or every Mastodon username is an RSS feed? Every Mastodon is. If you go to fosstodon.org, Taggart, I think this is how that works, right? Yeah, if you put a .rss at the end of my username, it becomes an RSS feed. And so anybody, if we do Kevin Beaumont, right? So if you wanted to do Kevin Beaumont, who's at what site? He has his own now, cyberplace.social. Go see the dog. Boom. There's Kevin Beaumont's RSS feed. In fact, why don't we use Kevin's? That might be a cool one to do, rather than the CISA one, which is like, it's useful, but kind of lame. Maybe we'll do both. We'll start with CISA and then we'll move on. So we'll start with the CISA URL. And in fact, we'll start this way by actually asking with an input. So RSS URL equals widgets. Equals widgets dot text. And we'll actually make this even a little bit cleaner. Label equals widgets dot label. And I believe label just takes a value. Yeah. Always have the documentation open. Pablo Tree and Chorizo Portuano, thank you so much for those follows. We'll set up a value equals RSS feed URL. And we'll just kind of put that there. And then we'll do... Oh, oops. I wanted that here. There we go. And say hbox equals widgets dot hbox, and we give it the label and the URL text, and we will display the label. Do I want text area? No. Value and placeholder. There we go. Got to actually give it data. Value equals placeholder equals RSS URL. Oh, I'm displaying the wrong thing. Display hbox. Hey, there we go. Now we actually have a thing. And so once we have this, will be updated dynamically as the code runs. So the next thing we'll do is go get the data. So get the data. Raw XML equals requests.get URL text.value. And we can try and accept this a little bit, be a little bit defensive. This is a simple way to do it. We can also do a few other ways, but a simple try and accept. Say print fetching URL text.value failed, which will say something about why. So we'll try to get that wrong first. So fetching blank failed, right? And now we run this again. Now it says bad URL failed. Notice that I didn't have to rerun this cell because this is already executed and loading the data into the notebook. So I don't have to rerun this cell every time I put more data in here. This is dynamic. One of the reasons I really like this. And I can just hide the code and just have my user interface control if I want. That is something I like to do, is kind of collapse the code I don't need. So I just have the parts that the user needs to see. I don't know Lythander. Unfortunate, I guess. Okay, so we have let's actually go get a real URL. Let's go get the CISA, the CISA current activity. All right, so we get the current activity now. It actually works, but we're not doing it. So we're getting into this try block, but we're not doing anything with it. So now we have to do something. What we doing? Well, the first thing we have to do is once again check. So if raw XML.status code equals 200, then we will continue. And we'll say soup equals raw XML dot text. And what's going to happen, let's actually just look at what happens with request.getRaw. So outside of this cell, what happens? If we do request.get with this URL, what do we get back? So we get response 200, it's a response object. But if we get the .text of it, it's just a big old string of XML. So this is what we're hoping to get back. And this is what we're going to pass to Beautiful Soup to parse it into something that Python knows what to make heads or tails of. Do you mind opening the RSS feed URL window for a minute? I don't know what you're going to get out of it, but yeah, here you go. Would you like the link to it? Here. There is the link to it. And this is also, you know, sorry, no, in the notebook. Oh, I got you. I'm sorry. I understand what you're saying. You wanted to see how the widgets were created. No problem. Yeah, we'll leave those open. Yeah, we'll leave the code open for now. I just wanted to demonstrate that you can collapse them for your users. Okay, so this is what we're after. And the text is going to be passed into Beautiful Soup. And we're going to give it the XML parsing argument. All right, let's just see if we have that much. And then print XML parsed. If raw XML. Yes, I did mean double equals. Thank you, Python. And it just says XML parse. Now we can clean up the logging. We can add color, actually, if we want, with the rich library. But for now, we're getting some good output. Why would you use a Jupyter Notebook like you have versus the VS Code capability of it? Oh, okay. So why would I use Jupyter Lab, I think is really the question. Because what our Brains is saying is, you know, Visual Studio Code can run Jupyter Notebooks. It has the ability to run Jupyter inside of it. Why would I want that instead of this? Here's why. So VS Code can run single Jupyter Notebooks at any one time. Jupyter Lab gives you an entire environment in which to develop. So I have a file browser, I have a built-in terminal, I have a built-in Python editor. Now you might think, oh, well, VS Code has all of that stuff too. It sure does. But we're not thinking about just ourselves. We're thinking about other people. And the eventual way I would like this to go for you is that after you've finished developing in Jupyter Lab, which I still think is a really nice development environment. I actually much prefer the way that notebooks are rendered in the first-party tool as opposed to VS Code. But after that, what I really hope happens is that you implement something like Jupyter Hub. And Jupyter Hub is a central server that is Jupyter Lab for your whole team. And so by developing your stuff inside of Jupyter Lab, you're already getting familiar with how that's going to look for your team. So, like, could you do all this with VS Code? Yes, there are some idiosyncrasies as to what you can do in terms of rendering inside of VS Code. I think the widgets are a little bit funky, and the plotting is a little bit funky. Whereas everything inside of Jupyter is specifically designed to work inside of this environment, right? So that is what I would prefer to do. Making a SOAR out of Jupyter Hub in a way. You could, let's pump the brakes on a SOAR out of Jupyter Hub. Think of it as, this is the way that I think of it. Think of it as a set of runbooks that execute themselves, right? So you have, there's automated components, but it's also, if you have a lot of SOPs or procedures that your team has to undertake, and a lot of it is rote, but some of it requires human input, that is a great candidate for something like this, where you can set up your parameters and just hit go. Two reasons for that. Not number one, then it's reproducible, but number two, the notebook, because you don't just write Python in these, right? You also write Markdown in these. Like the most accurate typing I've ever done. But because the documentation, the markdown can be interspersed very cleanly with images and diagrams, whatever you want to do, along with the code that is executing, the documentation and the tool are the same thing. And I find that very powerful. Okay, so we've got the XML. What are we going to do with it? Well, we have to understand the structure of the XML. So here, look at how this is built. We have the CISA current activity, there's a channel, and then there's a link. And then what we have is a bunch of items, right? So the first item, and here's the headline, and then the next item with a headline, and then, just kind of a bunch of that with some HTML encoded text, which we may have to handle. But to start, we will soup.findAll item. Because remember, Beautiful Soup is designed to parse structured semantic documents like XML and understand those tags. And sure enough, it can indeed do so. So it found a bunch of items, and for each one of them, we can extract the title, we can extract all of the links, or the link, and I think there's a description as well. Exactly. So we can use that to put together a little bit of a readable document. Wish Obsidian was smacked together with this. So yeah, I think that not everything that uses Markdown is meant to be put together. You know, one of the things that's cool is that GitHub will store the last run output to its best ability when you make a Jupyter Notebook. So like if you go visit a repository of Jupyter Notebooks in GitHub, you'll see some of the way that it runs. There are some things it can't do, like some of the cooler graphs, but all right, find all item. We're gonna, now that we know that works, we're gonna do items equals, or actually an XML parsed, and then items equals find all items. Then we have to, for each item, produce, what I want to do eventually is produce an HTML block for each item, okay? Here's what I'm going to do that. I'm going to produce a function before this, actually, called HTML item. And it takes a string. No, it doesn't, actually. It takes a Beautiful Soup object, my bad. But it returns a string of HTML. That is our function definition for now. And to do this, we're going to need something from the HTML library. Import unescape. I'll also mention here, since we're writing a function, that we're going to do our very best to do docstrings, because I'm going to show you a cool trick with Jupyter. Hey, some rando, good to see you. So docstrings are really important. They're something that you should do. And when you do them in Jupyter, you get superpowers. Observe. So HTML item converts Beautiful Soup XML item to an HTML string. Parameters. This is just this is actually taken from the PEP on docstrings, so it's convention. Item, Beautiful Soup, XML object. And that does something kind of neat. So we're going to run that cell. Now, down here, watch what happens when I ask for HTML item question mark. I get this cool help documentation built right in. notice that it has a really helpful signature, and then it shows me the docstring. Now, even if you're not in Jupyter, you can do this with the help function, because Python just has that. But inside of Jupyter, you can do that with a question mark. And by the way, you can do that with anything. So if I do like soup dot whatever, like adders, and I do a question mark, it'll tell me stuff about it if it's defined correctly. And that is why docstrings are so dang important. Okay, so now that we have this sort of defined, let's implement it. Yes, it is an IPython thing. That is correct. IPython being the ancestor of Jupyter. And if you've ever seen the stream, you know that I use IPython constantly instead of the regular Python REPL. So, not too tricky here. Basically what we're going to do, we know that we have a structure of like an item, and it has a title, a link, and a description. What does... We got channel, title, description, link, image. Interestingly... Oh, good. So we have items in Kevin Beaumont's as well. It has a link, and it has a description as well, which means that we can use the same structure. I think this is going to be true for almost all RSS feeds. That we're looking for items, we're getting the link. There's no title, which is a little bit trickier. We can deal with that. And then description. So we're going to start by building our item HTML. And we can do it in a multi-line string. Right, so we can do div and /div, and then we'll do, say, we'll try it with a title. This is gonna get a little bit funky. Item. Oh, can I do a multi-line format string? Item.title. Yes. Okay. Item dot title, or item dot title dot text, because the title is a tag, right? And if we want, we can make this a link, which we do want to do. So href equals actually, can I do a single quote? Yes, I can. Thank you, multi-line quotes. Item.link.text. Close that. Close that. Okay. Then we're going to do a paragraph. And we're going to unescape the item dot description dot text. There we go. And then return item HTML. Clean enough for now. We'll have to do something about the title for stuff that doesn't have titles. And that's easy enough to do. But for now, I think that'll work. So we'll define that out. So, by the way, so what's going on, in case this is new syntax for anybody, we're using a multi-line string with the triple quotes, and then the F prefix says that it's a format string, which means that it's going inside of my single curlies. These are statements. Learning how to use BS is also a good offensive cell. I know that you mean beautiful soup, but it works both ways. Yeah, I mean, scraping is an incredibly effective recon tool. All right, now so we're creating this div for each of these, and then we're just gonna soup.find all item HTML items equals .join. All right. Do we want to see some one-liner Python dorkery? Like, I can write this clean, or I can write this really nerdy. How do we want to do it? Nerdy, please. All right, you got it. First time chatter, FPV Hex. So here's the deal. We have a function that converts our soup objects, our item tags, into an HTML element, right? Now, we're going to create a bunch of them, and we have to concatenate them together, right? Because each of these is going to be a separate string. I need to put them together. Well, the goofy way of doing that is, like, if I have a list of strings and I give it an empty string with .join, see that? So what we'll do is we'll take that exact technique, and our list here is going to be a list comprehension. Arbrins, thank you so much for the support. I really appreciate it, and I hope you have a great game. So we're going to join HTML item I for I in items. So what we're doing here is we are taking this function that we've just defined, right? We are applying it to every item in our items list that we just got back from soup.findAll. And we are, so this becomes a list of strings, right? Because we know the HTML item returns strings. So we're using that against the blank string.join method to produce one big old chunk of HTML string. That is what that does. Okay, so we have HTML items. And then we'll print HTML generated. Let's just run this to see if it works. Isn't that a loop? It is a loop, but it is also a list comprehension. So this is it is syntactical sugar for producing iterative results. So rather than writing out, because a common pattern you'll see from new developers in Python is something like it's something like this, like ends equals 1, 2, 3. Okay? And then we'll say squared equals an empty list. And then for n in ends, squared dot append n times n. Right? And that all works, but we've just taken 4 lines. Instead, what we can do is say something like squared equals n times n for n in ends. And it's the same thing, but in 2 lines. So depending on what you're doing, this can be a little bit more elegant as a syntax. All right, let's run this. Okay, HTML got generated. Now we have to print it out. How are we going to do that? How are we going to render this? How are we going to render this? FPV Hex, please don't your questions are good questions. And if you're learning Python, so much the better. Please don't be embarrassed to ask any questions. I'm here to teach. So I'm excited to have you ask them. All right. Now comes a little bit more dorkery. Now we're going to render the HTML with a little bit more widget stuff. So we're going to just say render the HTML. So here we're going to say HTML out equals widgets.html, and we're going to give it the value of HTML items. And we'll even put a defense behind this to say if HTML items, right? Just to make sure it exists. And then display HTML out. There's more that we can do, but this is a good starting point. Well. We now have a feed of our RSS coming directly from that feed. Now, could it be cleaner? Sure. But it's a great starting point. Now, we want to make it pretty, right? We have to make it pretty. Okay. Here's the trick. Write some CSS and style tags. Whatever you want it to be. So if you want to, because these are links, right? So let's make it clearer that they're links. Let's say color. I have this color queued up, 9580FF, and then let's let's also say font weight boldest. Now, all we have to do is have style plus HTML items, because they're both just strings. And that's it. So all we have to do now, by the way, the links show up handy. We can also do text decoration underline. There we go. Now, this actually looks like a thing, right? All right, so this worked. We made an RSS reader. We made it for one URL, though. So the question is, can we do it for... What happens when we give it Kevin Beaumont's RSS feed? Right? How is this going to break? So we'll put this in, and then we will run selected cell and all below. So it says fetching cyberplace.social failed. Why? Raw XML.status code. It's at 200. So what happened? Oh, so the XML was parsed. Oh, but this part failed. So exactly what we thought was happened. So, yeah, we have to be a little bit careful here. Because this try and accept is no longer clean enough for us. Right? So we'll be a little bit more defensive here, a little bit. Now we can put that behind the status code because we have a protection there. And then we can say something like try. And then accept error is not defined. Was it generic error? No. I always hate the try except block for this reason. Python try except. Except value error. Yeah, but what if I wanted just a generic error? Except exception. There we go. Not error. Why was I thinking? Oh, because Rust. Thanks. Except exception. Yeah, I was in Rust mode. There we go. None type has no attribute text. Right. So the issue is coming from here. Right? The title. So we can split this up a little bit. This is gonna, we could do it as a one-liner, but it's gonna be awful. So we'll do it this way. If item dot title, then we'll say title HTML is like so. Else title HTML. We'll just leave it blank for now. And now that we've parameterized that, we can just toss title HTML in here. And now we've caught that error. Except that... Oh, because now it's a single format string. I need to escape these quotes. Wonderful. And what does that look like for us? Now, so this looks okay, but now we don't have a lot of dividing lines, and we didn't before either. So something we might want to consider is my old pal horizontal rule. Love that horizontal rule. And now we have Beaumont's entire feed. Now, if you wanted to, you could go crazy with it, right? You could filter it for specific terms. If you wanted to, you could say if anything starts, if you only wanted toots, they're not called toots anymore, but yes, they are, and not replies, you could get rid of anything that has an @ in there. It's nice that these are formatted correctly as links, though. Isn't that cool? That is not too shabby. Now, do we need dates? Maybe. We could add that in there as well, because we have a pub date. So we could add that as an option. But that's pretty good for a basic RSS reader for our first lab. Any questions on this? And by the way, to do multiple RSS feeds, what would you do? You would turn this into a text box, a text area with lines separating your URLs, right? And then split those up and then simply loop this part to combine all your items. Let's do that, in fact. Let's do that. Oh, these do have pub, so pub date is a standard. All right, pub date is a standard. We'll sprinkle a little bit more dev dust on this then. All right, so pub date is an actual thing. Okay. First thing is, we'll turn this into a text area. Yeah, it does. It has something. Text area, it's lowercase a. Well, that's just inconsistent. Okay, so now we can put in multiple URLs, right? If I can actually copy and paste. Nice. And then here's Beaumont's. Okay, now let me just run that, and then I want to see what that looks like. So we say URL text dot value. What does that look like? See how it has this \n? All right. Okay, well, therefore, raw XML URL text.value. URL text.value. So here's a cool trick. Did you know that split will use the new line by default? So I don't even have to give it an argument. It'll just split it at the new line. And so value.split, and now I have my URLs. The other thing I can do is I can make this into a function, which is exactly what I'm going to do. And this will return a beautiful soup object. So it's a little bit the opposite. Requests, XML, URL, and returns beautiful soup object. Actually, you know what we can do? We can have it return the list of items. And that way we can actually give it a list. Okay, so base case is return nothing. And URL, RSS feed destination, basically. Okay, and then we'll just take most of this out. Right, we don't need that anymore, but we are going to say r equals requests.get URL, and then we'll say if, there we go. We're going to cut this out. We'll put some more of it back in, but Soup equals beautiful soup. Print XML parsed. We will not do this anymore because that'll get noisy. Okay. HTML items. Print HTML generated. Return HTML items. So we have a way out of the function in both cases. Try accept. And here's a fun programming fact, especially a fun Python programming fact. I have an if, and then I have a return outside of it, which means I do not need an else. It's a little bit funky. You might say, oh, okay, I've got an if, and then I need to say else return this. But it turns out that those two things are logically equivalent. So I don't actually have to write the else here. I can simply say, if the status code is 200, do all of this work. That code will never get evaluated if the status code isn't 200. And so we just jump down to return the empty list anyway. So in both cases, we're returning a list. Perfect. Now, in here, now we could use the else for fetching the URL value failed. That might be helpful. And then return like that. So when you're doing more than just returning in the other case, then an else is handy. Actually, we don't even need it there either, do we? Because that won't... no, we do. Because that's a guard. We don't want this to print if this is happening. So we do want that else there. Now, URLs, text value to split, HTML items equals... You're going to love this. Get XML items u for u in URLs. Another list comprehension. And now the data, this process is much clearer, right? Because we have functionalized the process of getting the XML items. And I could, if I wanted, again, collapse all of this worker code so that only the small bits that I need to display are present. And then we can re-render. Can only concatenate stir, not list to stir. Oh, I forgot a step, right? Oh, yes, I did, because this should actually be .join. And this is why type hints can be helpful. Oh, come on, I did the thing. There we go. I was just a little fast. Let's put those back in. It was only showing Beaumont's stuff, which was interesting. Okay. That's all good. Run selected cell and all below. It is possible that that's because the pub dates are messing with it. Yeah, it's not displaying all of them, which is kind of interesting. There are some limits you can set for that. There are 17,000 of them. Good lord, Beaumont. That's why. So the other thing we could do, though, if we wanted, is with open e.html. There we go. As f. F.write. The HTML out, which is already saved as a... Must be stir, not HTML. Oh, interesting. Oh, because it's HTML items. Oh, HTML items is a string. Well, that's actually fine. So HTML items, it wasn't 17,000 things. So now that we've done that, if we go back to our, where we were scraping, I think. Yeah. So we actually wrote this out here, so we could do different kind of styling to put that in there. It's still only showing the Beaumont stuff, which is kind of interesting. URLs, URL text value dot split. Right, URLs. Yeah, I mean, that's working. Angel's URLs is stir? What? Ooh, interesting. This time it said U is not defined. Yeah, but I can still print them. It doesn't matter. That's not what's erroring out. It's printing out fine. Python knows how to cast. Python is implicitly doing that. So here's Python under the hood. When you call print on something, what's happening is you're calling the built-in double under stir method, which has the instructions on how to represent the thing as a string. And the list already has that capability. So that's not a problem. The problem is elsewhere. It's interesting that it's saying get XML items U for U in URLs. Yeah, name U is not defined. Get XML item. Does it need the brackets inside the .join? It absolutely does, because join is a list. Oh, wait, you know what? Hold on a second. We're 2 layers down. No, we're not. No, we're not. No, we're not. Because, we're already making them a string, and then we're just concatenating them all together. So actually, we're fine here. Unless... HTML items, return HTML. So this returns a list of strings, which I can be more explicit about here, actually. Which is good. Then but I'm putting them all together for all the URLs, right? So for every, it's like a, it's O n squared. So for every URL, we're converting every post basically, or every item into an HTML element. Name U is not defined. It's right there. All right, hold on. I'm doing something silly. Our code was working a second ago. Okay. Now let's see what this is. For you in URLs. So URLs is a list of strings. U for you in URLs. Works. Get XML item. You for you in URLs. Hold on a second. For you in URLs, print you. This is so weird. Okay. Print get XML item. You. What in the world? Okay. Interesting. So that's Beaumont's. Oh, God. I see the problem. I forgot to redefine this variable to R. It's still... Oh. And that's got to be URL. Okay, so now... Okay, so now we're getting the SYSA data. And I believe... Okay. There we go. Now, the trick is that there's one after the other. So the last part would be, how do you parse the date? Because we're getting one feed after another. The other thing you could do if you really wanted to be cool... this is where a real IDE will help you. Here's the thing, PJZ. It wasn't undefined. And this is an important thing to know about Jupyter Notebooks. As you run a cell... So, here, watch this. The order that the cells exist in have nothing to do with what a cell knows about. Observe. Print Z. Name Z is not defined. I'm going to go all the way down to the bottom here. Then come up here. Because it's about the order of execution. And so what happened was that my function here was actually, this function here was pulling in variables that had been stored earlier in my execution. If I had restarted the kernel and run everything, it would have properly yelled at me and said, hey, this thing isn't defined here because I forgot to change the variables when I messed it up. So it was Jupyter, behaving exactly correctly based on what it thought it wanted me to do. Ain't that always the case? All right. I think that does it for our RSS reader. This is a fun demo. It's one you can build on. The next thing I think we gotta do cool sysmon stuff, right? That'll be the thing that we do to end the launch party. This will take a second. All right, we'll go over to our advanced visualization. Perfect. And we'll make a new notebook because we'll do it from scratch. All right, so let's take a look at what we have here. We have a bunch of Sysmon XML. Now, I will say that the Sysmon library that is part of this course, which you're welcome to use outside of it, has the ability to parse both XML and EVTX format logs for Sysmon. So if you give it a raw EVTX file, it will parse it into the same kind of data as if you give it XML. It has two parsing functions built in. One of them is load XML and one of them is load EVTX. Either one will do the respective job for you. All right, so we've got a bunch of Sysmon data here. I'm trying to remember where this comes from. Where does this come from? We'll go do, this is our advanced visualization. Where does this come from? Oh, it comes from Splunk attack data. Right, this is a hermetic wiper. This is kind of cool. So if you're not familiar with Splunk attack data, GitHub. This is some gold. This This is really cool stuff. If we go into data sets, and then there's malware, and I think, yeah, hermetic wiper is where this particular one is coming from. But there are a bunch here that are worth checking out, right? There's Conti, Remcos, Revol, whatever you want to do. And then inside of them, they have... What is in this? Right, there's like metadata here. But more to the point, they have the raw data. As in, sometimes it's sysmon log, sometimes it's other stuff. So depending on what kind of attack it was. Data sets, there's malware. We were just there. What else? Attack techniques. So you've got some MITRE attack stuff here. And so in this case, right, you can see we've got sysmon as well as PowerShell logs to see Active Directory discovery. If you want to look at logs from attacks, you could do worse than the Splunk attack dataset. So thank you very much to Splunk for putting that together. We're going to use it in the exact wrong way that they want us to. They want us to load this data into Splunk, but we are not going to do that. We're going to load it into not Splunk. Anti-Splunk. So the first thing we'll do here, we'll call this visualizing sysmon, and then we'll import some Johnny Depps. First one is we're going to import sys. This is a little bit funky, but it's something that I found works well in Jupyter Notebooks specifically. Here's the problem. So, sysmon, I need this sysmon library in multiple notebook directories, right? And so I don't want to do like .. really when I do the imports, because that gets messy fast. So instead, what I found works better for me is sys.path.append, and we add the relative path there. And now that I've done that, I can do from lib what is it, from sysmon, right? Yeah, from sysmon, because it's directly in. From sysmon, which is now in my path because I've added that directory. Import, we'll do load XML in this case because that is the form of our data. We'll import pandas because we'll do some data frame stuff as PD, and we'll do some graphing with Plotly. Plotly Express. If you're not familiar with Plotly, I use it more than matplotlib. Most people, when they learn how to do graphing in Python, the first thing that they learn is matplotlib. And it's great. But there are a few things that it doesn't do particularly well. And one of them is the modern web. Because matplotlib renders your graph, your chart, as an image within Python. Okay? And so what you get is an image. It's static, it's one size, you can't zoom, you can't pan, you can't do any of that cool stuff. Plotly takes advantage of the fact that it's supposed to be run in Jupyter, meaning that there's a web interface, and so it has some JavaScript flavor going on in there that gives you a dynamic visualization that is interactive and allows you to export images as you need, but also allows you to move around and give some dynamism to the display. So I really prefer Plotly as my primary visualization tool. I also will sometimes use, depending on what kind of thing I need to draw and what's easiest, I will sometimes use things like Seaborn. Seaborn's good at a couple of specific things. Like error, it's really good at stuff that has that needs error bars. So I'll often use Seaborn if I need this kind of really rich, highly statistical data displayed. But Plotly is phenomenal at a bunch of things. I mean, look at this, right? It has kind of a nice showcase of the things that it can do. And it's, I don't know, quite lovely. Violin plots. And so this is kind of what I mean. So right, see how I have this interface here where I can pan around, I can zoom in. Ever tried bokeh? I have tried bokeh. The API is a little bit rougher for me. And it's so pretty. It is. I mean, it works okay. Use what works for you. I've kind of centered around Plotly for a couple of reasons. And one of them is that, yeah, so here's one thing that Plotly does well, and maybe Bokeh does as well, but I know for sure that Plotly does, is the time series stuff. And that was really what drove me to Plotly and away from other stuff, was that working with time was something I was doing so much of. As opposed to this, which is like, I get it. Well, let me show you how we do this in Plotly, and you can decide for yourself. So, first thing is we actually have to get our data. So if we're in advanced visualization, this sysmon.log doesn't come with a repo. So another cool thing I love about Jupyter is that you can run shell commands from inside of it with the exclamation point, and you can even give it data from Python, so, and pull data back. So like if I do stuff equals bang ls, and then I ask for stuff, I have a list of my files. And it goes the other way too. So if I said something like message equals hello from Jupyter, and we do echo msg message.txt, so that's cool. And for that, the reason that's cool is because I can do something like, if we do import os, and then if os.path.exists, sysmon, or if not os path.exists sysmon.log, what we'll do is we'll grab it directly from our Splunk data. Now in this case it is, but let's delete it and we'll run this code just so you can see what happens. Shell command. There we go. wget. There we go. So now we have the sysmon log. So this guarantees that it's going to be there for the rest of our work. All right, now that it is there, let's load it up. I'm going to call it events with EVTs. And so here's a little bit of a trick. If I load up my data, we'll call it, so events equals load XML. We give it the file name sysmon.log. This will do its work. And let's just do that in a single cell. That'll take a minute. Oh, that was actually a lot faster than I thought. So what are these things? They are Sysmon event objects. So if I want to know more about them, right, I can use question mark or whatever. But or I could use dir, find out its properties, right? I find out it has event ID, extract event data, image, parent PID, time created, user ID. Those are its attributes, right? in Python parlance. Browsing for Cookies asks, are you querying Splunk via API or just reaching out directly to log storage? I am reaching out to the GitHub repository to pull in the log data from the Splunk attack dataset. You could pull it in from the Splunk API if you wanted. You do have doc strings, right? Yeah, I do. The trick is that help is for methods more than anything. And so I actually prefer dir. And to the point, this object was created with the idea of using it not just for pandas, but for other work as well, which is why it's a Python object. However, what I can do for all of these things is run it through vars. And what that does is it turns it right back into a dictionary for me. And so I have all of the data that I need right here. Now, one of the things I may not need is the full beautiful soup object, but I keep it in there just in case I want to do something else fun with it. But I have the user ID, the event ID, the time created, PID, parent ID. So, in fact, what we'll do is we'll say vars e for e in load XML, because that will produce the dictionaries for us. And now when we look at event 0, it's much cleaner, right? It's no longer a Python object. It is in fact something useful to us for the next thing that we're going to do. The next thing that we're going to do is load all this into a data frame, a pandas data frame. So we'll turn that into a data frame this way. df equals pd.dataframe events. Take a look at that. df.head. Oh, you love to see it. So we're going to drop this soup column because it's unhelpful. df.drop soup axis equals 1, in place equals true. What that will do is it will just remove this column from the data frame, and then df.head. Now soup is no longer there, but the rest of our data is. Now, if we ask df for columns, it will tell us that it has these columns. But keep in mind that not all of the rows are going to have the same data. So for example, network connections of NID3 will not have data in the parent command line column. And so what I like to do after this is I tend to split down into the event IDs that I'm most curious about and then use the columns that I know have data from there. But for now, one of the easiest things we can do is look at our data by event ID. What kind of things do we have going on? Just raw volumetric analysis, right? So we could do something like df.group by event ID, and then we could do .count sort values by equals PID. And we, at this point, whatever we sort by doesn't matter because they're all, any column that has data in every row was fine to sort by because we've counted how many values there are, right? We haven't done any adding or anything. It's just how many rows that are grouped in this way are there. And then so ascending equals false. So we'll get the most common up top. And then we will ask specifically for what columns. We'll just get PID because it doesn't matter. And now we have a nice little table telling us what's going on with our event IDs. Now, this is the tabular version of the data. How would we do this in a graphical manner? Well, we could do something a little alike of this. We'll save this, actually. We'll save this events by ID. And the other thing we're going to have to do is, and this is just a pandas weird, a pandas idiosyncrasy. Do you see how the event ID label is offset from the PID label? What's going on here is that the event ID has become, because we grouped by it, it is the index of this new data frame we've created. What that means is that it's not available as a column of values for us. It is the way that the values are organized. And those are considered separately. So to get the event ID back, we're gonna .reset index here at the very end. And what that does .head let's try that again, is gives us, notice that we have this it's called a range index over here that is the default for pandas, but we now have the event ID as a column, which is what we want. All right, so now we're going to plot our events. So very simply, we are going to use the px.bar method, and I'm going to put this on multiple lines. So we're plotting the data frame, events by ID. I like that it's designed to work easily with pandas. The X is going to be events, or event ID. The Y is going to be the PID. And we'll give it a title to start. We'll say count of event IDs. Not too bad. Not too bad. Now, there are some weirdnesses here. So the first weirdness here is our axes labels. They're unhelpful, right? PID is meaningless in this context, so we got to fix that. And event ID, that could be a little bit cleaner. We can fix that by adding a labels dictionary. So we give it the field name, and then we give it what we want it to show. So event count, and we'll do event ID, and we'll just capitalize that so it's nice and clean. Much better. Now, what we can do... Oh, and I should mention that... Let's close tabs to the right here. I should mention that these are responsive. So if I were to shrink my window, it's not great at that size, but it does work. Very handy to have a responsive graph. Okay, so the next thing that's a little bit weird, actually, I'm curious if anybody in chat knows. If I'm looking at this, what is the next problem I have with this visualization? No takers. Wow, everyone's cool with it as is. I'm not. Your high Y in the last column is blowing out low values. It's not, because I can see everything that does have a value, except... And by the way, I mean, I guess I could go logarithmic, but that would be wild for just 0 and 3. The issue that I have is that this is not categorical data, but it should be. Right now, so event ID is an integer in this data set, right? The event ID is an integer. And because it's an integer, Plotly is like, oh. Plotly's like, oh, okay, it's a range of values. And that becomes very clear if we add a color column. So if we say the color is event ID, notice that it gives me a continuous gradient of values. And it does that when it thinks it has a continuous series, right? They're integers, but they're still on a continuous numerical spectrum. It thinks that it's quantitative data as opposed to categorical data or nominal data, which is really what the event IDs are. So the way that we fix that problem is we add a column here. So we'll do events by ID, IDster equals events by ID map, or no, events by ID, event ID dot, nope, event ID d dot as type stir. So what this does is it takes the existing series, and a series is like a column, but it has its own internal structure. It's not just a list, inside the data frame, and returns the values as a str. Just to show you what that looks like, let's just run that here, right? So that works. And we're going to assign that as a column. And then that becomes our X. ID stir. We'll replace it here as well. ID stir. And now it's categorical. Now, of course, the sorting on this makes no sense anymore because it's sorting. It was sorted by a number and now it's not a number anymore, right? But now we have the ability to see all of these. Now, if we wanted to, we could zoom in and see that there's very few of these, right? 6. You are not wrong that the scale is a little bit tricky because there's 1,000 of these. So if we wanted to do a logarithmic, we could. But honestly, the hover capability solves that really for me. Plus, between that and the tabular data and the ability to zoom, I'm not bugging about it. What I now know is, proportionally speaking, what am I looking at? And of course, I could do a pie chart if I wanted to. I hate pie charts. I don't think they're useful. All right, so that's event IDs. That's kind of like, that's easy days. Now, we can go a little bit deeper. Let's go into one of the specific event IDs, right? Let's investigate network connections. So the way we can do that, right, is we'll save network connections with a slice on our data frame. Our original data frame, mind you, not the one we just made by event IDs. And we'll look for everything that has an event ID of 3. And then we're going to do something kind of cool. So let's look at just that. Okay, so this is every network connection that we have. This is a lot of data. What I want to do is I want to group them in a specific way that is useful here. And the way that I want to do it got event names, map them. I mean, yes, you can do that. I prefer to do the event IDs just because for my purposes, I have them memorized and they're the things that I'm organizing by anyway. But yeah, you can do event names if you want. But no, so what I want to do here is I actually want to take two pieces of information from network connections. The first is the image that the network connection came from, and then the desk port. Okay, so these are the two things that I want to see at first. And so... and the count of them, right? So what I'm going to do is I want to group them by the image in the destination port and then see how many connections there were that had those specific images and destination ports, right? So like, what did this program do at that port and how often did they do it is the question I'm trying to answer. So to do that, I'm actually going to take this and group by, and you can group by more than one thing, which is kind of interesting. To see it, we'll do a count. It gives you a two-layer index, right? See how both image and desk port are offset? So I can use this to doubly group my data. From there, again, I'm going to reset the index. And I want to plot my destination port on my x-axis. I want to plot the count of connections as my y, right? So where was it going? How much of it was there? And then my color, this is where we get into that third dimension, will be the image itself. So the color of the bar tells me what was doing it. And then the destination port on the x-axis tells me kind of where was it all going. To make that happen, I am going to change this up a little bit. We're doing px.bar again, but we're gonna this is another way of creating categorical data. So we're gonna do network cons once again. Then we're going to do the x equals the destination port. The y is going to be the user ID, which we know that we have in every column. PID would work fine too. The color, as I said, is going to be the image. And then the labels, we're going to change this up a little bit. So desk port, we're going to make a little bit more human friendly. It's going to be destination port. The user ID is going to be connection count, because remember, that's our count value. And then our title will be connections by desk port and image. All right, let's give that a go. So that kind of sucks. And the reason it sucks is because the destination port, once again, is considered as quantitative data as opposed to categorical data. But I need it to be categorical data. Another way to fix this problem, Plotly actually has built in. But in order to do that, we have to save the figure to a variable and then call some methods on it. So we'll save it here and then fig.update x-axis. And update x-axis allows us to change certain properties. In this case, we're going to change the type property to category. So that's much easier than adding a new column made of strings, right? And then fig.show will re-render the chart. Nice. That gives us a lot of cool data. And again, this is a nice one that benefits from the zoom in, right? Where we can really see per port what was going on and who was doing it. And this, I think, is really important to know, right? So, and again, this is important to know even for non-malicious data, right? Understand what your services are doing. So for example, LSAS, it makes sense that it's calling out to port 389 LDAP, right? And SVC host probably as well. And Active Directory Web Services. But what if you had something like SharpHound? You would see it here as well. And that may be a little bit more interesting. A lot of DNS requests in here from DNS.exe and SVC host. This 8089, that's Splunk being Splunk. There's more Splunk being Splunk. And then we have some other strange ones, right? 445. And then these RDP. This gives us a lot of information. Now, we also have incoming connections, right? Which is why Deskport is high random. But the point there, of course, was just to demonstrate. So you have a couple of ways to generate categorical data, and that is another one. And again, this is the first time we've seen multi-dimensional analysis where you have an x-axis, a y-axis, two different values, and then using the color as another way to tell more of the story. Because if we didn't have that, right, we lose so much richness in the visualization, right? Now we just see, all right, here's the port. But just by adding that extra layer, now look at how much more we're learning about what's taking place. All right. Last one. This is where we're going to do some time. Our data frame chrono analysis. That's not really what it's called. It just sounds cool. Our data frame has a time created column. It even has one that has a pretty solid date time string. If you've ever worked with date times in Python, you may know that they are a screaming nightmare. That's some awfully transparent Guinness you have there. You're not wrong, Sar. You can't get the good stuff here in the United States. It's my favorite glass. But, no, I've been spoiled because I've actually had S in Python with nothing. Yeah, you're not wrong. I feel like Python is uniquely terrible. It's... Alright, here's tonight's sentence. Date times in Python are so bad that I prefer working with them in JavaScript. That's how bad they are. Because you have both, you have a time library and then you have the date time library, and they're totally different things. And then to create a date time, wow, so here's why. Because we'll go to docs.python.org. Nope. Why does my autocomplete not work tonight? Yeah, because the datetime library is a mess. Why no clicky? I'm not sure what's wrong with my browser, but I can't click on things. But mostly you ignore the date and time libraries and just use datetime. I know. It's still bad. The datetime library is still poorly organized. Working with time zones is an utter nightmare. So, the good news is that Pandas makes it much easier. Because Pandas has a toDateTime method. This is so nice that I have used it for totally non-Pandas related stuff when I just need data frame, I need datetime stuff, because it has a really rich parser for date times. So what I will do is I'm going to add a underscore time column to my data frame, kind of the way that Splunk has an underscore time field. That's where I got the idea from. And I'm going to say pd.toDateTime, and we'll give it, if I can type, df.time_created. And that just kind of works because the string happens to be well structured. But if I give pd.toDateTime garbage, this is my favorite one. So I don't know if you've ever had to deal with syslog date times. Let me get one. Or no, just tail. Who did this? Why is this a reasonable timestamp in syslog? Right? So if I do pd2DateTime on this thing, it will fail outright. Syslog date times are ctime based. I don't have to use Maya. The point is that Pandas has a format key that allows me to use strf time or strp time syntax to fix this problem. And rather than importing a bunch of other libraries, this often is a much nicer solution, especially at scale. What is it? Percent seconds. And then this is almost right, except that now it's it's the right day, but very much the wrong year. It's the year 1900. So the way that we solve that problem is with the pd.dateOffset, and years equals 122. And now it's the right day? Yes, that's why. And so Pandas has everything that you need in there to make that work pretty well. Yes, I know that I am aware that there are other libraries that can make date times a little bit better, but the first party stuff is yikes. Okay, so we've got our date times though, right? We now have an underscore time, and notice that it says that it's a datetime 64 object. So we know that we have proper date times in here. That is good. Thing is, there's a lot of them, right? If we look at the shape of our data frame, it's 3,712 records. So depending on how they're stretched out, it may be a little bit much. So let's say we want to group by time. How do you group by time in Pandas? Let's say we wanted to create groupings of every 10 seconds, maybe. There's a little bit of art to figuring out what your resolution should be there. But depending on, you can say like, you can do df.head, or actually, you want to do df sort values by equals underscore time in place equals true. And then if we do head, all right, we learned that the first time created is, right, so February 25th, 12/19/27. And then if we do, let's just do df head 1. That's a little bit cleaner. And then df.tail 1. Okay, so we learned that our range is from 12/19/27 to 12/29/25. So essentially 10 minutes worth of data over, what was it, 3,700 records. So, do your division for that. I'm going to try first at every 10 seconds. To make that happen, and once again, you're going to use a group by, but I'm going to use a new kind of group by. Pandas has this thing in it called a grouper, which allows us to create grouping objects other than the built-in columns. So our grouper is going to look like this. It has a key of our column, which is time, and then a freak, which takes formatted time amounts like so. And we will count that, and we'll look at the head just to see what that looks like. Now you can see that we're getting, and by the way, per every 10 seconds, we're getting a fair number of events, right? So notice that it goes 1920, 1930, 1940, 1950. So we're now grouping by a certain amount of time. And again, we could do this by different resolutions, right? Every 2 seconds, every 5, depending on what the resolution should be for what we're attempting to visualize. So we're going to take this and we'll call it events by time. And instead of head, we will say reset index again, so we get our time back. And now the time column that we got back, right, is those 10-second intervals, but there's still now a column available to us. So we can do with this, we can create a line chart this time with our events by time. Our X, of course, is going to be our time series. Our Y is going to be anything that's a count. So again, PID is fine. Title, we'll say events over time. In this case, a 5-second interval, but we would change that depending on what we were doing. And then for our labels, we'll do something like our time is going to be time, and then our PID is going to be event count. All right, let's give that a crack. That's pretty good resolution. If we bring it up to 10 seconds, we bring it up to 10 seconds. Did I turn insert on somehow? Yes. Oh, no, I didn't. I just forgot the S. I did. Okay, there we go. All right. Point is, if we turn it up to 10 seconds, obviously it's a much lower resolution. If we kick it up to 30, it's even less. So, and if we go down to 2, that may in fact be too noisy. This may not in fact be telling the story that we want to tell here. Whereas at 5 or 10 seconds, what are we saying? We're saying something to the effect of, all right, pretty baseline, something in terms of just raw event count, something was going on here at the 12:20 mark, but then something for sure was happening at 12:25. And so if we were looking at just volumetrically, something off baseline was happening on our system in this time horizon, we would focus our investigation here. Of course, we can still do better. What if we add our color and make it event ID? Oh, sorry, I forgot a step. So what if we grouped by 2 things, right? We want to group by time, but then we also want to group by event ID. So here, we're going to add this to a list. And then the second thing we do is event ID. And then if we do color equals event ID, we will learn a little bit more about the story. Yeah, look at that. So now we know for sure something across different event IDs was happening that was pretty interesting in this zone here. We know that we have a bunch of registry events. We have some network connections, which is worth taking a look at. We take a look at more registry, event ID 6, file rights, also important to see. So again, a bunch of registry though. So this may not be malicious. It's just that it is anomalous from a volumetric perspective. And it's not a bad starting point. If you're looking completely without any context, like what happened on this system, what was weird, because understanding baselines is really important, right? If you can understand baselines, then the weird stuff jumps out at you. And with a tool like this, you can do it absolutely mathematically, right? You can determine what your baseline is. In fact, you can, for your events by time, I mean, we did a count, right? But then we can do, for those, we could do a sum total. We could do averages to say, so events by time, right? We have events by time. Let's say PID, right? Which is a single column. But we can get its average. So we say, okay, so we have an average of 5 events across event IDs. But if we filter down further to say how many event ID 11s do we have on average, and then how many above our central tendency is a specific point in time, now we're starting to see actual deviation from baseline. As a matter of fact, you can even find out what a value standard deviation is and understand, all right, if you're like 1.5 off of that, then you should be taking a look at it. For outliers, and then one last trick is if we turn this into a bar. Now again, we have our categorical issue, right? And in this case, because it's the color, what I might do is say what we did before, right? ID stir equals EVTs by time dot event ID dot as type stir, and then we use the ID stir, and now we get this really nice picture about how this was broken down. And you could imagine doing this by different images as well to get that kind of analysis going. How would you go about picking the time frame in which to perform the standard deviation? Yeah, you want as much data as possible, basically. The smaller your data set for that, the less likely it is to be representative. So you want to just grab as much as you can, really. And I would say that especially for things that have constant uptime like servers, at least a week of data, right? And you can set up, if you haven't played with Perfmon, if you haven't played with Performance Monitor, in Windows, start, because that is a great way to get some of this performance data baselined. You can get perfmon data and you can toss it into Jupyter just like we're doing here and run analyses on it as well as use the built-in perfmon tool. Perfmon is unbelievably well built. I don't like complimenting Windows, but it's a really good piece of kit. And the fact that admins can run perfmon against remote systems makes it even better. So you can set up perfmon jobs from your workstation and collect the data remotely. So and that's built right into the tool. So yeah, I have baselines on machines, and for workstations and things like that, I like to do a week of data where I'm collecting. And by the way, the samples get huge. This is a lot of data. The samples get huge, and you're talking about, I like to sample, if I'm doing a week, I'm sampling every 30 seconds. I need to have within a minute worth of execution. And if I'm doing less than a week, I'm going to 10 seconds. So depending on how many metrics you're collecting, that gets big quick, right? So be aware of that your perfmon data will be a little bit beefy and will take some time to process unless you have like a Hadoop cluster or something that you can toss it at. Generally, when I'm doing performance data, it's very, very basic, unless there's something specific that I need. Oh, hey, Matt. Something very specific that I need, but generally speaking, what I will do... Hold on. This is kind of off Jupyter, but... perfmon is cool. If you've never done perfmon, let's make a new data collector set. New data collector set. I will create one manually. Performance, thank you. And let's add some performance counters. So I will add... Look at all the stuff you can beget. These are all built in. But processor, right? So percent processor time is easy enough, right? And then that's total. Or I could split it from all instances to get all my cores if I wanted. And then see how it has the / Odyssey. So if you wanted to go, if you were in a domain, right, and you had some admin privs on remote computers, all you would do is drop the host name in there, and now you're setting up counters for a remote machine. You can also use the command line version of perfmon logman. Yes, you can. I find it a little bit more difficult to set up collector sets on the command line, but you can absolutely do so. You can do network. Be aware, network adapter, network interface are subtly different, depending on what you want to do, right? If I'm doing network adapter, you're looking at the actual like NIC, virtual or otherwise, whereas network interface is essentially the device, right? The hardware that you have. So bytes total, or if I want to split received and sent, I can get those in there and start running the job, at which point I will start pulling those in, and then I'll start getting data. The built-in grapher is pretty rudimentary, but you can export the data into CSV or other formats as well. So yeah, perfmon, very cool. Not really a pure security tool. It's definitely more an ops thing. But here's the truth is that especially persistent malware or things like miners and stuff like that, they're going to show up in the ops data as performance anomalies, right? And so you can use that as another way of looking at what's going on if you have good enough baselines. But yeah. All right. So that is, I think, where we're going to leave it for tonight. Bit of a shorter stream, but As a reminder, this was all in celebration of the launch of Python for Defenders 2. If you are interested in checking it out, you can get it at the Taggart Institute right now. And because you are here for our launch party, you get 50% off until midnight Pacific on December 9th. So essentially 24 hours and change to go get 50% off with the code SOFTLAUNCHVIP when you check out and get Python for Defenders Part 2. And don't forget that Part 1 is also still available and free, as are the rest of the courses at the Taggart Institute, including the amazing Responsible Red Teaming from my friend and partner Husky Hacks, who has done just an amazing job with this course. If you want to learn about the ethics of operating in an offensive manner, right? How do you emulate the bad guy without actually being the bad guy? We have an amazing course from the one and only Sarsec about binary exploitation, which will walk you through basic binary exploitation, basic buffer overflows, and then teach you the defenses that have been put in place, like address space layout randomization, like stack cookies, and how to get around them. So if you want what I think is really the most comprehensive explanation of the theory behind binary exploitation, you got to go check out this course, and again, totally free. So I hope to see you over there on the Taggart Institute. I hope you'll enjoy Python for Defenders Part 2. The paid courses like PFD2 are essentially just to cover the operating costs of the Institute and make sure that we can support other course authors. So thank you very much. I hope you enjoy it, and I'll be back on Saturday with some more red teamy, blue teamy, purple teamy stuff. But until then, let's go see if there's anybody from the hack list who is streaming. Well, we have Nahamsek who's live. But we also have Day Zero. And so I think we're going to give the little guy a raid rather than Nahamsek. All right, so we'll raid Day Zero. But other than that, friends, please be good to yourselves. Be good to each other. And happy hacking. I will see you next time.